Hello and good morning. My name is Arya Peruma and welcome to today's webinar. Today I will be going over how to solve system of equation problems when there are two variables. And today we will be going over different variations of these kinds of problems, specifically going over the methods of substitution and elimination. In addition, I just wanted to thank everyone for their feedback on the last two sessions. I had received a few questions asking if there would be a webinar on solving system of equations problems with three variables, and the answer to this is yes. So if you are interested in registering for that webinar, all information can be found on our website. Also, keep in mind that this session will be recorded and will be posted to our website shortly after this session. And the link to that is posted in the chat and is also displayed on the screen you're viewing right now. So with this, let's get started with our very first question, which we will be solving using the method of substitution. Okay, so the very first problem we will be looking at today is y equals 6x minus 6 and negative 3x minus 3y equals negative 24. And we will be solving this question using the method of substitution. All right, so let's get started with solving this problem. So as you can see, this is a system of equations problem, and you can see that there are two separate equations here. So using the substitution method, so as you can see, the very first equation here, y equals 6x minus 6, there's actually a value for y already given. It says in the question directly that y is 6x minus 6. It's giving you a value for y. So this can be the case with any problem like this. It can either give you the value for y or x, and just using that value, you need to substitute the value they give you into the second equation. So I'll show you what I mean by this. So it states here in the problem that y is equal to 6x minus 6. This is the value of y. So looking at our second equation here, I'm just going to name the first one equation 1, and the second one I'll just be naming equation 2. So taking a look at equation 1, this is where they give you the value for y. We know that y is 6x minus 6. And then looking at equation 2, we have just an equation with x and y variables on the left side. So since y is already isolated here in the first equation, it's giving you the value. What you can do is substitute that value for y, 6x minus 6, that's the value for y they give you, and substitute it for y inside the second equation. So this will look like this. So taking equation number 2, I'm just going to do negative 3x minus 3 times 6x minus 6, which is equal to negative 24. So as you can see, I've just taken the value of y, which they have given us, which is 6x minus 6, and substitute it wherever you see y in the second equation. So now, as you can see, everything is in terms of x. There are only x's in this new equation we've created. So now it's really easy to solve for x. And we can now solve for our variable x. So now we're just going to solve this algebraically as we regularly would. So taking a look at this, we have minus 3x, and then we have minus 3 times 6x minus 6. We're going to be applying distributive property here by just taking the term on the outside of the brackets and multiplying it with each term on the inside of the brackets. And remember, what separates the term is either a plus or minus sign. So we're just going to be applying distributive property here. So we have minus 3 times 6x, which is negative 18x. And then we have minus 3 times minus 6, which is positive 18. So we're just going to be writing plus 18, and that just equal to negative 24 as in our equation. So now we've come to this. Minus 3x minus 18x plus 18 equals negative 24. And now we're just going to be collecting like terms. So on the left side, we have minus 3x and minus 18x. Those are like terms. We can combine them. So I'm just going to be writing minus 21x. That's what you get when you do minus 3x minus 18x. And then we're just going to be writing plus 18 equals negative 24. And now combining like terms even further, we have a minus 21x and plus 18 on the left side, and we have a minus 24 on the right side. So I'm just going to subtract 18 on both sides in order to isolate for x and also combine like terms. So doing this, I have subtracted 18 on both sides. So looking at the left side here, we have negative 21x plus 18 minus 18. 18 and 18 cancel out. So we are just left with negative 21x on the left side. And then we have minus 24 minus 18 on the right side. And just adding those and combining those, we have negative 42. So now keep in mind we want to find out the value of our x variable. So we need to isolate for x. We have a negative 21 multiplying with x at the moment. So in order to isolate, we need to perform the opposite operation to what is attached to x, and it's being multiplied by negative 21. So we're going to be dividing both sides by negative 21. So dividing both sides. On the left side, we have negative 21x divided by negative 21. That's just x. And is equal to negative 42 divided by negative 21. And that is equal to 2. And here we have our x value. So we're halfway done here. So as you can see from our original question, we had both x and y variables present. So we actually want to find out the value for both x and y. We figured out the value for x, and using our value for x, we can easily figure out our value for y. So what we're going to do is similarly how we substituted what we had for our y value, 6x minus 6, given by the original question, into y into equation number 2, we're going to be doing the exact same thing by taking our value of x, which we found, which is positive 2, and substituting it into either equation 1 or equation 2, wherever you see x. So you can do either. You can really substitute 2 into equation 1 or 2, but I'll just be picking equation 1. So the equation 1 is y equals 6x minus 6. So wherever you see an x in that equation, we're going to be substituting 2 into there. So y equals 6 times 2 minus 6. All right, so we substituted 2 into where we see x in equation number 1, and now we're just going to simplify. So y is equal to 12 minus 6 because 6 times 2 is 12, and 12 minus 6 is equal to 6. So therefore, y is 6 and x is 2. So we've discovered our x and y values, but there's just one final step we need to do. And this is to write our x and y values in coordinates. So the reason we're writing them as a pair of coordinates is because these two equations, y equals 6x minus 6 and negative 3x minus 3y equals negative 24, are both equations for lines. And by finding out our x and y values, what we have for x and y, we are basically finding out the intersection at where the x intersection point and the y intersection point of those two lines. So by writing it in coordinates, we're basically saying that these two lines, equation 1 and equation 2, the lines for equation 1 and equation 2 intersect at an x value of 2 and a y value of 6. So that's basically the same thing as writing the coordinate 2, 6. And just going to write that out, 2, 6. So this is basically the intersection point, 2, 6. The coordinate 2, 6 is the intersection point of these two lines, as these are both equations of lines. And that's basically the final step you need to do. Keep in mind that you're going to be writing this exactly as you would write coordinates. You'd find them, x value first and y value second. So x value was 2, we wrote that there, and y value was 6, and we wrote that there. And this is our final answer. X equals 2 and y equals 6, and writing it in coordinates 2, 6. All right, so this is it for the substitution method. And now we're going to be moving on to the second problem, which I will be solving using the elimination method. So let's move on. So our second problem, we have x minus 2y is equal to negative 13. And then our second equation is 4x plus 2y is equal to 18. And I'm going to be doing the exact same thing as before by just naming the first one equation 1 and the second equation here equation 2. And we're going to be solving this one using what we call the elimination method. Okay, so as you can see, this problem is a bit different compared to the previous problem we solved, as the first problem we solved together had a value of y already established. The question gave you the value of y. However, in the case of this problem, there is no value of x or y they're going to give you. It's just the x and y variables are on the left side, and we have a constant on the right side. So we can't really solve this using the same way by substituting. However, this is where this method called the elimination method comes in. So the elimination method is basically adding these two equations by eliminating either an x or y variable. So as you can see here, our first equation is x minus 2y equals negative 13, and the second one is 4x plus 2y is equal to 18. So in order to eliminate a variable, we need to make sure there are opposite coefficients on both of them. So when you just look at this problem, you can see that there is a negative 2 as the coefficient of y on equation number 1 and a positive 2 for the coefficient of y on equation number 2. And as I stated previously, what we need to do for the elimination method is basically we're trying to add the equations, add them. So adding the x values, y values, and the constant values. So in order to add them, we need to make sure that we eliminate a variable so we can easily solve for one variable first and then solve for the other one. So as you can see, there are opposite coefficients on both y variables for both equation number 1 and 2. There is a negative 2 and a positive 2. So if you add those will basically cancel out. The the variables which are in terms of y would be canceled out. Minus 2y and 2y would be canceled out if you add them. So you'd be left with only things in terms of x, which would make it really easy to solve for x and then later on solve for y. So since the question already gives you variables which have opposite coefficients, the y's here have opposite coefficients, one has coefficient of -2, the other one has a coefficient of 2, you can easily add these and eliminate y because of this. So adding these two equations, we have x plus 4x, which is simply 5x. We have minus 2y plus 2y, which is just 0. Y cancel out, the y variables cancel out, so we're just left with nothing in terms of y, which makes it really easy to solve for x. And then looking at the right side, the constants, we have negative 13 plus 18. Negative 13 plus 18 is positive 5. So this is what we have so far by just eliminating the y variables. So now that we have this, we can isolate for x further to figure out our value for x. And by doing this, we just need to divide both sides by 5, as 5 is being multiplied with x right now. So dividing both sides by 5, we can cancel out the 5 which is being multiplied by x. So 5x over 5 would be 1. So it would just be x. It would be x. So 5x over 5 would be x, and 5 over 5 would be 1. So we have our value of x as 1. So now that we've discovered our x value, we can easily now figure out our y value. So in order to figure this out, we just need to do the exact same thing we did in our first question, and we're just going to be substituting our value of x, which is 1, into either equation 1 or equation 2. So I'll just select equation 1 for right now, but you can select equation 2 also if you wish to substitute x into. It really doesn't matter. So I'm just going to select equation 1 and substitute 1 wherever I see x. So equation 1 is x minus 2y equals negative 13. So I'm just going to substitute 1 minus 2y is equal to negative 13. So we just have 1 minus 2y equals negative 13. And now, combining like terms, I'm going to subtract 1 on both sides. So 1 minus 1 minus 2y equals negative 13 minus 1. So I've subtracted 1 on both sides. So looking at the left side here, 1 minus 2y, the 1's cancel out, and we're just left with negative 2y. And now looking at the right side, we have negative 13 minus 1, which is negative 14. And we have to remember isolate for y. So isolating for y, we're going to be dividing both sides by negative 2, as negative 2 is being multiplied with y. So we need to perform the opposite operation. So that's division. So dividing both sides by negative 2, we have negative 2y over negative 2, which is just y. And we have negative 14 over negative 2, which is 7. And this is our y value. So therefore, we've just figured out our x and y values. X was 1 and y is 7. And remember, we need to do the exact same thing as last time by just writing it in coordinates. And I've explained why last time in our last question. Basically, this is the intersection point of these two equations of lines, as these are both equations for lines. So this is basically the intersection point of these two lines, and that's why we're writing it in coordinate form. So here's our answer, 1, 7. In other words, x is equal to 1 and y is equal to 7. This being the x value, this being the y value. And there we have it. This is our final answer for this question. So now we're going to be moving on to our final problem, which we're also going to be solving using the elimination method. So I'm just going to write this out. So the problem we'll be doing, question number 3, is 5x plus 10y equals 20. Equation number 1, and minus 6x minus 5y is equal to -3. We'll call this equation number 2. So now looking at this problem, we're also going to be solving this using the elimination method, same method as we used in our previous question. And we're going to be solving this using the elimination method. So this method is the exact same as we used in our previous question, but as you can see, the question itself here is a tiny bit different. So this is because, unlike the previous question, you're not given the opposite coefficients for variables right away. Like in the last question, you were given minus 2y for the coefficient of y for equation number 1 and positive 2y for the coefficient of y in equation number 2. So you're already given opposite coefficients for your variables, so it's easy to add these equations up and just eliminate a variable. However, in the case of this question, you are not given that. So you need to make that yourself. And what I mean by this is you want to multiply both equations by something. They don't have to be the same numbers, but you need to multiply both equations by numbers where when you multiply them, you can create opposite coefficients of either x or y. So then when you add those equations up, you can eliminate for either the x or y variable. It really doesn't matter which one you eliminate for as long as you eliminate a variable. So what I'm going to do here is just going to write this out. Just going to quickly write this equation out again. And I'm going to show you how to create opposite coefficients. So looking at our first equation, 5x plus 10y is equal to 20, you can clearly see that there are no opposite coefficients to the second equation. So in order to create this, we need to take a look at these two equations. So let's just take a look at y, for example. First, you need to determine which variable you would like to eliminate. If you would like to eliminate the x variables, take a look at the coefficients of x for both equations. If you want to eliminate the y variable, take a look at the coefficients of y for both equations. It really doesn't matter which variable you eliminate. So for right now, as I'm showing this example, I am going to be eliminating for the y variable. So taking a look at the coefficients of y on both equations, coefficient of y here is 10, and then we have a -5 for equation number 2. So if I multiply this whole equation, equation number 2, by +2, you can see that when distributing this, we can achieve 2 times -5y, which is going to be equal to -10y. And if you add 10y plus -10y, as there's a 10y over here in our first equation the for the coefficient of y is 10, if we add these, you can clearly see that they will eliminate, they will cancel out each other. So the y's will be gone. Everything in terms of y will be gone, and we'll just be left with x in order to solve for that and isolate for x. So let's do this. I'm going to multiply this by 1. So taking a look at equation 1 and equation 2, we multiplied equation 1 by 1. So that'll just leave us with 5x plus 10y equals 20. And I multiplied equation 2 by positive 2. So 2 times negative 6 is negative 12, and then just x, as we need to add the x to it. And we have 2 times negative 5y, which is negative 10y. And then we have 2 times negative 3, which is negative 6. So now, as you can clearly see, we've made opposite coefficients for a variable. We've done it for y. But you could also do this exact same thing for x by figuring out which numbers you would need to multiply with equation 1 and equation 2 in order to create opposite coefficients for x. So in the case of this question, you would need to multiply equation 1 by 6 and equation 2 by 5 in order to achieve and get 30x for equation 1 and negative 30x for equation 2, which you could then add and cancel out, leaving only y to isolate for. So you can isolate for any variable you desire. You just have to pick and choose which one you want to eliminate for. So now, taking a look at what we've done so far, we've multiplied both equations by numbers in order to create opposite coefficients in front of a variable. Now we can just carry out the exact same steps as we did in question number 2 by just simply adding these. And adding it, we will get 5 plus negative 5x plus negative 12x, which is negative 7x. We have 10y plus negative 10y, which is just 0. The y's just cancel out. 10y and negative 10y will cancel out. And then we have 20 plus negative 6, or in other words, 20 minus negative 6. And that will give us 14. So as you can see, this is how we can eliminate even when the question, does not give equations where there are opposite coefficients for variables. So we can create these. And I will let you answer and solve this question yourself. I urge you to try it yourself. And I will just provide you with the answer so you can check back your work and you can see if your answer matches my answer. So the answer to this question is negative 2 and 3. Keep in mind these are coordinates. And keep in mind that this is the x value and this is the y value. So negative 2 is the x value and 3 is the y value. And I encourage you to try this one yourself and complete it yourself to see how you can solve this and figure out the x and y values, and then just check your values with this answer. And I will just give you a few moments to just copy down the question and the answer. All right, so hopefully you've copied it down by now or took a picture of the screen. And now with this, we have come to an end of the session. So I just wanted to say thank you so much for attending today's webinar. I hope you enjoyed and was able to take away something new and useful from today's session. So just another friendly reminder that this session is recorded and will be posted to our website shortly after this session. And the link to that is in the chat and is also displayed on the screen you're viewing right now. In addition, the next webinar will be on application of linear equations in word problems. And keep in mind that these sessions are free, so if you know anyone who is interested or would benefit from these webinars, feel free to let them know so they may register for next week's webinar. So once again, my name is Arya Peruma, and I thank you for attending today's webinar, and I hope to see you next week. Thank you and bye.